Let us explore some rational functions which do not have any restriction in domain. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here we have a very important question based on rational functions. The question here is, can there be a rational function without any holes or vertical asymptotes? Justify your answer. Part B is, write a rational function with domain x belongs to real numbers and range y belongs to real numbers so that y is greater than 0 but less than equal to 1. Graph your function. You can always pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, send an email on the address given. Here is a very interesting question. Most students think that the rational functions will have restrictions, right? But many don't. Let's try to understand what a rational function is. So rational function is quotient of two polynomials. So let's say one in numerator, the other one in the denominator. Now since denominator is not equal to 0, that gives two restrictions. But many times we could have denominators which are never 0. So those are the functions where we may not have any vertical asymptote or holes. Makes sense, right? Let me give you one example, right? So let's talk about a rational function r of x equals to 1 over x squared plus 1. Now see, x squared plus 1, is the denominator ever 0? It is always greater than 1, right? Since it is always greater than 1, it has no restrictions at all. Correct? So that is the answer for part A of our question. Make sense? Now let's look into part B. Write a rational function whose domain is all real numbers and range is less than equal to 1, but greater than 0. Well, the function which I wrote meets this criteria. See, the domain is all real numbers, right? Now let's talk about the range. So let me take it on a fresh page. So we're talking about the function which I'm defining as 1 over 1 plus x squared. As you see, it has no restrictions at all. Now it is a reciprocal of 1 plus x squared, right? So if you have to sketch it, a very simple way to sketch is something like this. You can sketch the function 1 plus x squared, which is a parabola 1 unit above the x-axis, as a minimum, right? So the function has a minimum right there, and this is 1 plus x squared, correct? Since this does not have any x-intercepts, there is no question of having vertical asymptotes, right? Okay, now what is the reciprocal of this? Well, the reciprocal of this will be kind of like this. Do you see that? Makes sense? So that is the function. So here you can see that the range is what? Well, the range in this case is y belongs to real numbers. We see that y is never touching 0. It is approaching 0, right? So we have a horizontal asymptote which is y equals to 0. So y is greater than 0. However, y is less than equal to 1, as you can see. So it meets the criteria for part B of this particular question. You get an idea, right? So we could have many rational functions where the domain is all real numbers, right? So you can see that the domain is what? So domain is x belongs to real numbers. Perfect. And the range in this case is restricted as shown here. I hope that makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.